Welcome to PressGrid. So this is network and security training, job-oriented training. Today we will discuss IPv4, subnetting, network ID, what is the host ID, uh, what is the subnetting, how to do the subnetting of the network, basically how to convert from big network to smaller networks. So today's lecture is very important. You must know the IP addressing and how to subnet to become a network engineer, right? It's a basic things and foundational of networking. So as you see here, IP addressing. There are two types of IP addresses, IPv4, IPv6. IPv4 addresses are a core component of the Internet Protocol version 4. What is IPv4? It's a core component of Internet Protocol version 4, IPv4, which is a protocol for use on packet switch link layer network, layer 3. When we talk about layer IP addressing, we are talking about layer 3 in the OSI model. We discussed the OSI model, 7 layers model. It's also called 7 layer model. So IP addressing at the layer 3. So IPv4 addresses are 32 bits. So in other words, like 4 octets of 8 bits each. So 1 octet is equal to 8 bits. Numbers that are usually represented in decimal format as a 4 numbers separated by period. For example, 192.168.1.1 or 128.68.1.1. Each of the 4 numbers can range from 0 to 2 to 5 to 55. Okay. So IP4 address range is 0.0.0 to 255.255.255.255. This is the range. So if you see anywhere IP addressing where 256.256 or dot 300, no, it's wrong. It cannot be IP address. Okay. This why? Because this is the IP4 address range. This addressing schemes allow for 4.3 billion unique addresses. So two computers cannot have the same IP addresses. IPv4 is the most widely used version of the Internet Protocol. Even in today's eras, in 2024, 2025, it's most widely used version of the Internet Protocol. It assigns a unique address to each device on a network, enabling them to communicate with each other. The large-scale growth of the internet has led to shortage of IPv4 addresses. Why? Because now we have billions of cell phone, right? Billions of devices and people are using all over the world. And that's why it's led to shortage of the IPv4 addresses, which has been addressed partly through use of the network address translation, NAT. We'll learn NAT in the next, what is the netting in the next few lectures after doing the switching and routing labs. So don't worry about that right now. Just get yourself familiar with the term. And the development of the newer version IPv6, which is use longer addresses, okay, which is longer than these addresses. But let's first understand IPv4. What is IPv4? How it works, right? Before we jump, deep dive into IPv4, I want to brief you about or remind you decimal to binary. What is decimal to binary? Because it's very important. This is the decimal number. So as a human, we understand the decimal number 0.0.0, 255 or 128, right? These are the decimal number. But computer understand everything in 0 and 1, binary. So it's very important for us, to convert decimal to binary, at least for IPv4 range. Okay. So decimal to binary, this is the formula. If you see here, decimal number nth bit multiplied by 2 raised to power n minus 1. And as you see, what's the IPv4 address range? 0.0.0 to 255.255.255.255. And these are the 32 bits. How it's 32 bits? Let's take a look here. So first thing I want to say, you can easy to memorize it, right? when it comes 0, when you have to convert decimal to binary, it's all 0. These are these are the 8 bits, 8 bits, 8 bits, and 8 bits. So one 8 bit is equal to 1 octet. So these are the 4 octet, right? So 0 is very easy and simple, right? If you have to convert decimal to binary, everything is 0. So you make it 0, 0, 0, 0, 80 again dot 80 dot 80. And same way, this is our range, right? So what is the maximum range for IP4 address? 255.255.255.255. So again, this is also very easy. If you want to convert 255 into 8 binaries, all one, dot 81, dot 81, dot 81. How? We'll take a look how it comes, 8 ones. Okay. So let's take one example here. Uh, so how you calculate here, I created simple formula, this chart table. So first bit, right? First bit, what is the first bit? Is made out 2 raised to power 0. When you do 2 raised to power 0, it comes 1. And second bit is 2 raised to power 1. So when you do 2 raised to power 1 means it's 2. That's been basically 2, right? Third bit, what is the 2 raised to power 2? 2 multiplied by 2. That's come 4. What is the fourth bit? 2 raised to power 3. So 2 multiplied by 2 multiplied by 2. That comes 8. Similar way, 2 raised to power 4. You multiply 2 4 times. 2, 2, and 2, right? And that comes 16. 2 raised to power 5 means you multiply 2 into 5 times, right? 2 multiplied by 2, 2, 2, 2, 5 times 2, and you multiply and you get the 32 value. Similar way, 2 raised to power 6, you get 64. 2 raised to power 7, you get 128. So these are the 8 bits. And this is how you convert it, right? And again, as you see, 0, you make it all bits set as a 0, and your value becomes 0. And for 255 maximum value, you set all bit as a 1, right? 8 bit, fourth bit, third, second, and first. How you do it? Basically, your 8-bit value is 128. So how we get the 255? Let's calculate here, right? You basically do the sum of all the values and it comes to 55. But how? When you set bit here, 1, value comes here is 128 multiplied by 1 plus 64 multiplied by 1 plus 32 multiplied by 1 plus 60, 16 multiplied by 1 plus 8 here, right? So 8 multiplied by 1 plus 4 multiplied by 1, and this is the value, plus 2 multiplied by 1, and this is the value, plus 1 multiplied by 1 is equal to 255. How? 128 multiplied by 1, you get the 128. So plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. So this is how the value you get it. Basically, you set bit 1 or 0 to make sure that your sum value becomes your decimal number, right? Whatever. So now if we need 128, how we get the 128 here? Let's take an example here, right? So 128, you basically set only first 8 bit as a 1 and the rest 0. So right, so when you multiply by 1 with the 128, it's become 128 plus you set this one as a 0 because now you messed your value right here. What you need 128, right? And this value matches here. So 64 plus 32, but this value becomes 0. Again, this value becomes 0. This value becomes 0. Why? Because we only need 128. And if you set 1 here, you get 128, right? So plus 0, plus 0, plus 0, plus 0, right? So what's your value comes here? You set first value 8 bit as a 1 and the rest all 0. 7th bit 0, 6th bit 0, 5th bit 0, 4th 0, 3rd bit 0, 2nd bit 0, first bit 0 is equal to 128. Okay, let me. Okay, so now we take a look at the 64. How 64 will come here? What we need? So we got the value 128 is 1 0 0 0 0 0 0, and similar way 64. So for 64, when you set this bit as a 1, so 1 multiplied by 64, you get your value 64. So you just only set this value 7th bit as a 1, and the all rest bit 8, 6, you everything set as a 0. And now what value you need? 3. So if you 3 means if you set 128, 64, 32, 16, 8, 4, right? If you set this all bits, your number will increase. It will become more than 3. So what do you do? Basically, we 8 bits set as a 0 because it's more than 3, right? 64 is larger number than 3. Again, 32 is larger than 3. 16 is larger than 3. 8 is larger than 3. And 4 is also larger than 3, right? But when you multiply, when you set this bit as a 1 and this bit as a 1, your sum will become 3, right? So you don't need the third bit as a 1. So that's why you make it here 0. And now your second bit you set as a 1. So 1 multiplied by 2 will become here 2, right? Plus 1 multiplied by 1 will become, so 2 plus 1 is equal to 3. So that's why you set this 2 value as a second bit and first bit you set as a 1. And now we take a 1 here, right? So we already know if we just set the first bit, so that's mean we get value 1. So 1 and then rest all bits become 0. So it's very easy, right? Let's take another example here. Uh, Here I'm not doing writing here. Maybe it's better. So 192. How we get the 192 value? So we set this bit as a 1. Seventh bit we set as a 1. And the rest, sixth bit we set 0. Fifth bit we set 0. Fourth bit we set 0. Third bit we set 0. Second bit we set 0. First bit we set 0. So basically 128 plus 64. If you do sum of 128 plus 64, your value is 192. So what is the binary value of the 192? 1 1 0 0 0 0 0 0. And this is how you get 255, right? So I set all bit 1. If you see here 128 multiplied by 1, 64 multiplied by 1, 32 multiplied by 1, 68, 4, 2, 1 multiplied by 1. So when you do sum of all this value, 128 plus 64 plus 32, 16, 8, 4, 2 plus 1, that is 255. So memorize these two things, right? When you need 0, it's all 0. And your value is 255, that's mean all 1. So when you need to find any value between 0 and 255, you need to make sure that it should not be all 0 and it should not be all 1. Why? Because for 255, all 8 bits are 1. So if you are looking for 254, that's mean you can't have all ones, right? That's a simple logic. So for 254, what you need here, 254 minus 1. So you don't set this bit as a 1. So 254 will become 1, 1, 1, 1, 1, 1, 1, and 0. That's your value, 254. And now let's back here 168. So you need 168. What we do, we set 8 bit as a 1, and if you add 128 plus 64, that will become 192. So that's larger than 168 value, right? So we don't set this one as a 1. We set simply as a 0. So this will become 0. And now if we come here 32, so 128 plus 32, what is that number? 160. Yes, I think we need this value, right? In sum. So that's why I said this value is a 1. And 160 plus 16, that will become 176. So that value will become larger than 168. So that's why we set this one as a 0. Now we already did 128 plus 32, so that's 160. Now if we set here 8 number, right? If you this bit as a 1, so that's if you add this value 128 plus 64 32 plus 8, that will become 168, right? So that's mean our binary value is 1 0 1 0 1 0 0 0. This is our binary value of the 168. I can write it here. 1 1 0 0 0 0 0 0. And here 1 0 1 0 1 0 0 0. And 32. What is the value of 32? Basically, we already know that if we set the 6th bit as a 1, we get our value 32. So you set only this bit as a 1 and the rest 0. So 0, 0, 1, 0, and then again 4, 0. So these are the 8 bits. So this is the decimal to binary. Okay, we got the 1. It's very simple, right? You set the first bit as 1 and you get your value. So you set 0, 0, 0, 0, 0, 0, 1. It's very easy, right? If you what you do if you need 2 means you set the second bit as a 1. So that means 0, 0, 0, 0, 0, 0, 1, 0. This is your second bit. What would you do if you need 3? First and second bit you set as a 1, right? 0, 0, 0, 0, 0. What would you do if you need 4? You set fourth bit as a 1. So this is our fourth bit. So I set 1 and then rest 0. So remember this value, right? If you need 8, you set fifth bit as a 1. 1 and then 0, 0, 0. Sorry, fourth bit as a 1 here. All right. And 4 means third bit as a 1. So it's very simple and easy. Okay, this is how you can you can convert binary to decimal number. So make sure you remember this. When you see the two all ones, that means it's 255, and all zero means it's 0, right? So all you need to do is you need to find value between 0 and 255. So that's like 1 to 254. And that's what we need in the networking concept. So now let's take a look at the number of hosts and networks, right? For each class A, in the first lecture, we take a look at the what is the range of the IP addresses, right? Class A IP address range start from 0.0.0 to 127.255.255.255. And these are the fixed, like a default network ID and host ID. So you will understand when we do the lab what is the network ID and host ID. Okay. So host ID, that's mean number of hosts you can have it. in that network. All right. So class A, so first octet, right? So first octet, or you can say here this one first number 0 dot. That's your become the network ID, and the last three digits is your host ID. So here we are talking about decimal number, right? So in the class B, first 128.0, this is your network ID and it can be within this range. So host ID. So class B, it's very simple, right? Two digits for network ID and two digits for host ID, right? First two digits for network ID. So always remember one thing that your network ID is starting in the first digit or second digit, and the last digit would be your host ID. Okay, so class C, we have a first three digits 192.0.0 to 223.255.255. That's your network ID. So in simple, right? In the class C, your network ID would be, it can be anything from this range 192.0.0 to uh, 223.255.255. And you can take any here, right? 220.220.220. And this can be your network ID as well, right? So anything within this range is your network ID. And how you calculate that number of networks for class A, you do 2 raised to power. When you are looking for network ID, you subtract 1, right? You don't consider all 8 bits. 2 raised to power 7 minus 1, because 0 in the class A, 0 cannot have, you cannot assign 0 to network, right? 0.0.0.0. You cannot assign any network or anything. So it's always start with a 1, right? So that's why 2 raised to power 7 minus 1. So in the class A, you can have 127 networks. You will get more clear in this concept how we are talking about networks, right? Right now, it might be confusing to you, but when we do subnetting in the next lecture, you will have more clear understanding of what is networks. And then again, when we do labs, your concept will be clear. Okay. This is the thing, you just need to memorize it and remember what is the network ID for class A, class B, class C. So number of hosts, how many number of hosts we can have in the class A? 2 raised to power 24. How we got the 24? We got 24 from the digits, right? So remember, our IP4 is a 32 bits. So we have a 4 octets, right? First, second, third, and four. And each octet has a 8 bits. This one had 8, this one has a 8, this one has a 8. So our first octet is a network ID, and the last octet is a host ID. So when you do sum of these three, 8 plus 8 plus 8, that's become your 24. And why we are doing 24 minus 2? Because two IPs are reserved, one for gateway and broadcast. So we configure for gateway, and the last IP of the network is always used as a broadcast. The last IP of the network. Okay. And in the class B IP addresses, so we know, right? The first two octets are network ID here in the class B. So 2 raised to power 14 is equal to, this is the value we get. Now we don't have to do minus 1 because there is no 0 in the class B, right? IP. So 2 raised to power 14 is 16384. This is the number. And how many hosts we can have? 2 raised to power 16. How we got the 16? Because we are considering only last two. So 8 plus 8, that's a 16. Minus 2, why? Because one IP is for gateway and second IP we use for broadcast. Last IP. Remember, last IP always being used for broadcast IP addresses. Now class C. Class C has a first three octets, right? So 8 plus 8 plus 8, right? This is. But when we look at the network ID, we don't consider we only consider 7 bit here. So 2 raised to power 21 is equal to 2097152. This many number of networks you can have in the class C, but you can have less number of hosts in the class C. So now class C we have only last octet left, so that's why it's 8 here. So 2 raised to power 8 minus 2. Why? Because gateway and broadcast. And this is also called class pool IP addresses. So again, remember when we go from class A to class C, our network ID become larger, bigger, and the number of hosts becomes smaller, right? In the class A, you can have so many hosts, and the class C, you have less hosts, right? You can have only 254 hosts. So let's take a look of the how class A networks looks, right? When you assign what is common here, if you see in this here, 73 is a common. Why? Because this is our network ID, and 73 is common here, right? So spatial, this is a broadcast. So that's why this is the last IP and we use as a broadcast. But first IP we always use as a gateway. That's why you cannot assign this to. This is a spatial block, right? You remember 0. We cannot assign it to 0. So that's why this is a spatial block. And network ID here, 127. This one is again spatial block, right? So in a many operating system, you uses a loopback IP address. That's why you cannot assign this one. What is a loopback IP? You will learn it later. Okay, don't worry about that right now. So network ID here in this you can see is 73, right? But it can be any within this range. What is the class A range? It start from 0.0.0.0 to 127.255.255.255. So you can have any from 1 to 26. So similar way, right? If you have 74, you can have 64 as well, or you can have any number. Okay. Now let's take a look at the class B. Same here. What you see common here in this left side picture, 180.8, because this is your network ID and this is your host ID. So 180.8.0.2 that is assigned to this PC. This one is assigned to this router, right? So this is again remains your network ID and this is your spatial broadcast. And here, what is the range for class B? I start from 128 to 192, 191.255.255.255. This is the range, right? You see. So what are the network ID you can have in the class B? These are the default, okay? So you can have any starting from 128.0 to 191.255. So you are covering 171.255 or you are covering everything between these two numbers, okay? And what are your host ID? This last two digits are host ID. So in this one, your network ID is 128.0 and your host ID can be 0.02 to 55.255. And in this one, network ID is 180.8, right? And this is your um, host ID. And this is the third example, right? 191.255. This is your network ID and this is your host ID. How many addresses you can have in here? 65536. Okay, this many addresses you can have in this range. But always remember two IPs are reserved. But again, now in some of the cloud environment, they will reserve four IPs or five IP addresses for multiple purpose usage. We'll learn it later. Don't worry right now. So let's take a look of the Class C, how Class C network looks like. So Class C has a first three digits are network ID 200.11.8. And what is the Class C IP address range? It starts from 192.0.0 to 223.255.255.255. This is the range. So you can have anything between this, your network ID. So one is 192.0.0. So again in the Class C, this one first you always use as a gateway and the last you as a broadcast. So you can have only 254 host IDs. You can host basically you can say computer or any end devices. So you can assign anything starting from 2 to 254 to any of the hosts of your computer. This is your Class C IP addresses. And in here example, what is the common here? 192.0.0, 192.0.0. This is your network ID. And first is always gateway. Last is a broadcast. So that's why it's special, right? And you can assign starting from 2 to 254 to any computers or any host or any devices. Similar here. What is the common here network ID? This is our network ID. So this is for broadcast and dot one we use for gateway. And you can assign 2 to 254 to any computer. Same here network ID. What is our network ID? This is the network ID 223.255.255. How many you can have addresses? You can have 256 addresses. But what are the usable address? Minus 2, 254. Now let's take a look all together, right? How class A, B, C looks like. So class A address is first. This is our network ID, right? And the class B you can have 2 141.14. This is your network ID. And class C, 3 digits, right? This is your network ID. So network ID is specific in the network. You can't change it, right? And host ID, basically you can assign any IPs starting from 123 here 123.0.0.1, but one we use for gateway. So I would say 2 to anything here 255.255.254 because 255 again used for broadcast, right? Now let's look at two-level hierarchy of a network. So only one network here. We see this is the class B, right? So we have only one network here, 141.14.0.0. This is the network, right? So first two is our net ID, last is the host ID. So you see here it will change, right? 2.20, 2.21, 2.104, 105, 7.96, 7.95, 7.44, 22.8, 22.9. But what is the common in everything here? The first two digits, 141.14, because that's our network ID. And you see it's more complex, right? Let's make it more complicated to manage it here. But what if we, divide and organize? If we divide into smaller pieces and convert it into smaller things, right? It's easy to organize. So for that, we call subnet. So subnet is also called subnetting or subnetworking. So basically, a large network is logically or physically divided into multiple small networks. That's called subnets. The reason for subnetting as a large network is to address network congestion and its negative impact on speed and productivity. So in other words, If you want to optimize network performance, what you do, basically you create larger network into smaller networks. So smaller networks are easy to manage, right? In other words, think about an event, right? Think about an event where you host a concert, right? Where 10,000 of people are attending the concert. What will happen is sometimes it become chaos, right? Even if you need some drinks or anything, right? Or foods, you can't go outside or you cannot buy anything, right? Because you are in a concert where so many people, you cannot hear to each other. But if you organize that into smaller room, let's say you are studying in your classroom where you have 30 or 40 students, it's easy to manage, right? Your professor can easily explain it to you and easy to manage it. But similar way, again, it's smaller networks, right? Smaller groups. And then you are working on the projects, or only three people are working on that projects, right? So it's easy for you guys to collaborate, communicate, and deliver the project on the time, right? And that's why smaller networks are basically that's mean better performance and better security. So subnetting also improve efficiency, right? Due to the way of address space is utilized in a small network. Finally, the division between subnets allow organization to enforce access controls, which improve network security. So if you have smaller networks, you can, you know, configure the security by using the access control list. We'll learn that in the later sections after the routing and switching labs. So it's enhance the security. Router table entries can be minimized, right? Easier to number the host. You don't need to worry about the large digit in the class AIP addressing. And again, in other words, what is subnetting? A bigger network is divided into various smaller network for internal use within the organization. While for external world, it is treated as a single network again. So that's a subnetting. Let's take a look. What is the subnetting? So similar example, right? We just saw 141.14. If I go back here in this slide, similar this example, right? 141.14 is our network ID. Now, if you see here, it's a little bit complicated, right? It's not organized. But now after subnetting, what happened? So this is after subnetting. 141.14, 2.0. So basically we create a smaller group for this one that's is within the 2 dot range, right? And anything comes for 141.7, we put into separate group. So basically separate group is a network subnetwork. And again we created one more group, 141.14.22, right? 141.14.22. So this is again we created third group. So it means subnetwork. So now it's even if you look at it, right, it's easy to organize basically, right? And you can configure the security at each layer as well, and it's better for performance, right? You can optimize performance. So now let's take a look how we can do subnetting. So we need to uh, beats from the host part, right? So as you know, what is the network ID and host ID? So network, this one has a each you see here each digit has a 8 bit. Okay, this one is technically converted into 0.00010. So this one has a 8 bit, this one has a 8 bit as well, this one has a 8 bit, this one has a 8 bit. So what we do, network ID remain the same. So you borrow the bits from the host ID. So here this is the example of the class P. So class P has a 16 digits of the host ID. So this one is right now if you want to convert into 21 into binary, how we do? I simply remember 1, 2, 4, 8, 16, right? 32, 64, 128. So I said 0, 0, 0. Yes, we need 16, right? So 16, 4 means 1001. This is 21, right? So 16 plus 4, 20, and plus 1 is equal to 21. So this is our 8 bit, and this is 8. So this is the 16 bits. What we have to do, we need to borrow bits from the host ID. Okay, so you are borrowing the bits from the host ID, and this is the without subnetting. You look at here, and with subnetting, we borrow the bit from the host ID. So you borrow two bits, like a two digits, like two bits here, right, or one bits, and that will become your. This is now become your subnetwork access. And what is the host here? Host ID. This is the host ID with subnetting. And without subnetting, it's look like this. With subnetting, it's look like this. You borrowing the bits from the host ID. Again, remember, you are borrowing the bit from the host ID. Now let's discuss about what is a subnet mask. So every device on the network has an IP addresses. A subnet mask splits the IP addresses into the host and network addresses. And this helps define which part of the IP addresses belong to the network and which part belongs to the devices or host. So what we do, if anything, if you see here 255.255, this is the subnet mask. Okay. Basically, you convert binary to decimal, decimal to binary, and you get this value, right? 141.14. So you subnet mask. The subnet mask is a 32-bit number where all the host bits are set to 0. So all host bits are set to 0 and the network bits are set to 1. So whatever bits are set to 1. So remember this is a 32 bits. So this 255 you see is means all ones, right? And 255 means 8 ones and 0 means all zeros. So where 1 represent the network prefix and 0 marks the host identifier. This is for the host identifier. So IP addresses ended bitwise with the subnet mask give the subnet address here. So this is without subnetting. Without subnetting for any class P, this is the default subnet mask. For class A, default is 255.0.0.0. Why? Because in the class A, you can have only first digit as a network ID. So network ID, you convert everything into ones. Whatever your network ID, basically you convert everything into ones. And if it's a class C, your subnet mask would be 255.255.0. These are the default subnet masks. And now with subnetting, what happened here? With subnetting, if you subnet and if you consider this one is a one network, and so this will become your network ID. So your network ID becomes all one and host ID become all zero in the subnet mask. So what is here? This will become all one, so it's 255. 14 value will become all one, so it's 255. This 2 will become all one, so it's 255. And dot 0. Host will become the 0. Host, or you can assign it to devices, assign this. So these are your default subnet masks. You remember network ID. So your first network ID, first bit is your first digit is your network ID. Anything in the class A range, you cannot have 0 and 127. So you start from 1 to 126 digits, right? So if you convert that decimal number into binary, this is your number. So for all class A, default subnet mask is 255.0.0.0. And that's also considered as a slash 8. Why slash 8? Because we have only all ones, right? 8 ones. So that's why we use a slash 8. So whenever you see the slash 8, that's mean 255.0.0.0. This is your subnet mask. And now class B, you see here two digits, right? and start from 128.0 to 191.255. So anything from here 128.0 to 191.255 become the all ones. So 8 ones and 8 ones. So all ones value will become 255.255.0.0 and 8 plus 8, this is less 16. In class C, you already know the class C, the first three digits, right? 192.0.0 to 223.255.255.255. So your first three digits become the all ones. So that means here 8 plus 8 plus 8. So that's 24. This is it, like subnet mask. So it's easy to find the subnet mask. Okay. Now let's calculate the subnet mask. In the class B network, if we borrow the three bits right here, now you see here, this is the default subnet mask of the class B, 255.255. 255 means all one. Again, all one, 0 will become 0. 0 is 0, right? And these are the slash 16. We can call this is the slash 16 because these are the 16 bits and these are the 16 bits. Is easy, right? So in the first one, how you calculate the number of subnets? You can have it 2 raised to, when you borrow the 3 bits here, now you want to create like divide this larger network into smaller networks, right? So how you do it? You borrow the 3 bits, this 3 bits, and now your this will become the network ID. Initially our network ID was only 16 bits, but now our network ID is 16 plus 3, 19 bits. And how we calculate here? 255, all ones mean 255. 2224. So we remember we only borrow the 3 bits. So 3 bits, if we look at it here, right? How we get 1224 value? Again, remember this value 1, 2, 4, 8, 16, 32, 64, and 128. So we do 1, 1, 1, and then 0, 0, 0, 0. So 128 plus 64 plus 32. What is that value? 224. That's how we get the 224. So our new subnet mask will be 255.255.224.0. So this represents the network ID. And now we have a 13-bit slabs, right? 16 minus 3. So 13-bit slabs for the host. So you can have host within this range. How many hosts you can have it? 2 raised to power 13 minus 2. Remember, the last one is for broadcast, right? The last IP we use for broadcast. And the first IP we use for gateway. And that's why minus 2. So how many hosts you can have in this, the new subnet mask? You can have 8190. Okay. Now let's take a example. For an example, I would say we borrow the 4 bits. What will happen, right? Here I show you 3, but fourth bit. I want to borrow the fourth bit as well. What would be the subnet mask for fourth? So first, again, this is the 255, right? This is 255 dot. Now we need to see, I want to borrow the fourth bit as well. So simple, 1, 2, 4, 8, 16, 32, 64, 128. So I borrow 4 bit, 1, 1, 1, 0, 0, 0, 0. So our host ID will become 16 minus 4 because we are borrowing the 4 bit. So this is 12 bit, right? And here we are doing is 2 raised to power 4 minus 2. What is that value? 2 raised to power 4 means 16 minus 2 is equal to 14. And now we are doing 2 raised to power 12 minus 2 is equal to 4094. 2 raised to power 12 will become 4096. So 4096 minus 2 is equal to 4094. Now we need to calculate 128 plus 64 plus 32. So if you add these three, you already know what is the value? 2 to 4. But 2 to 4 plus 16, right? 2 to 4 plus 16. So here 128 plus 64 plus 32 plus 16, 240. Simple. You add 16 plus 2 to 4. So that will become 240. This is your new subnet mask, and this represents the network ID. For 3 bit this one, and fourth bit is this is the network ID. Okay, so it's very easy. You need to do more practice on it, right? I think then it's become super easy. If you do like 10 15 more practice for each and every, like how to convert subnet mask, how to divide the networking decimal to binary, binary to decimal, it's very easy. All right, thank you so much. And the next lecture we'll discuss more about the VLSM. Uh, VLSM, how to do subnetting. VLSM is a variable length subnet mask, and how to do subnetting as well. I will deep dive into subnets, more concepts. Thank you.